Okay, so Math 3, Unit 2, Section 3, Part 2. So we've written some information at the top. In order to help us solve, we're going through these steps. The very first thing I need to do in each problem is isolate my absolute value to the left. So on this first example, is my absolute value isolated? Yes. There's nothing additional outside the absolute value, so we're isolated. Number 2, is this problem a special case? No. This 12 is not negative, so it's not a special case. Number 3, we need to determine whether this is an AND problem or an OR problem. So some of you already have the answer, which is perfect. It is an AND problem, in fact, but I'm going to show you a little bit more information on that. So if I have a number line with 0 here in the middle, absolute value is talking about the distance away from 0. That's why it's always a positive number. Okay, so this means my distance from 0 needs to be less than 12. So if I have a positive 12, it has to be somewhere between 0 and 12, but it could also be between 0 and negative 12, because that's still a distance of 12 away from 0. Focus. Okay, so these distances are both 12 from 0, correct? If it has to be less than 12 away, then we know that all of these numbers in between are going to work. Let's take a look at the next one. First of all, that one's not isolated, so let's isolate it before we do anything else. Okay, now it's isolated. And I have a greater than or equal to sign. So that means my distance from 0 has to be greater than 6, could be equal to 6, or also the distance from 0 can be further away than negative 6 is, which would be a number that's less than negative 6. This is not what you're going to graph your number line at the end. This is just for the part that's inside the absolute value. So this 3/4 x right here has to either be greater than 6 or less than negative 6. That's why we split it into 2 equations, and this one is called an OR problem because 3/4 x is greater than 6 or 3/4 x is less than negative 6. We're going to end up writing those out. You can even write it now so that we can end up solving that later. 3/4 x is greater than 6 or 3/4 x is less than negative 6 or equal to. But we also want to go back and do the first one before we get too far. We know our distance has to be less than 12 away, but this is talking about the 3x minus 9, not the answer. We still have to solve more. But we know this 3x minus 9 has to be between what two numbers? Negative 12 and positive 12. So we literally write 3x minus 9 between the numbers negative 12 and positive 12. What sign should I put in between here? The less than sign. We want negative 12 to be less than all of this in the middle, but we want all that in the middle to be less than positive 12. Okay, and that piece in the middle is 3x minus 9. So these are the 2 different cases that we have when we're talking about step 3. We can have an AND problem where you have something in the middle of 2 numbers. You can have an OR problem where your value inside the absolute value is either going to be greater than the positive number or less than the negative version. So whenever you change to the negative version, make sure you flip your sign.
Why do you have to flip the sign?
Because if you take the opposite number, you have to take the opposite sign. Just like when we're multiplying or dividing by a negative. All right, over here, now we can start solving for x. What do I need to do to isolate x? Before we divide, we want to make sure we get rid of addition and subtraction, so we add 9 to all 3 pieces of our inequality. Negative 12 plus 9? Negative 3. And 12 plus 9 is 21. Is x isolated? Not yet. We need to divide everything by 3. Alright, negative 3 divided by 3 is negative 1. I divided by a positive, so I don't need to flip any sign. 3 over 3 is 1, so that just gives me 1x is equal to x. And 21 divided by 3 is 7. The way I read this, negative 1 is less than x, which is less than 7. In other words, x has to be the answers between negative 1 and 7. So, solve the following absolute value inequalities for x. That's what we just did. There's a lot of instructions at the top, so don't miss anything. And graph the solution on a number line. Here's negative 1, here's 7. Is your x going to be on the outside or in between those values? In between. Can x be equal to negative 1? No. Can x be equal to 7? No. Only the values in between negative 1 and 7. So you can shade it like that, or you can do a solid line across, either way. Alright, this was an OR problem because I have a greater than symbol. So we need to solve each of these separately. So, for the first one, how do I solve for x?
Multiply by 4.
Okay, so I heard multiply by 4 to each side. So I get 3x is greater than or equal to 24. What do I do now?
Divide by 3.
Divide by 3. I'm going to write my answer below. X is greater than or equal to 8. Or I should have another answer. What do I do to solve over here?
Multiply by 4.
Multiply by 4, and I get 3x is less than or equal to negative 24. And then, just like the first problem, I'm going to divide by 3. X is less than or equal to negative 8. So this is my inequality answer. X is greater than or equal to 8, or x is less than or equal to negative 8. We need to write the solution on a number line. Don't let me forget to go back and follow the rest of the instructions because we skipped something on the first one. Okay, write the solution on a number line. Here's negative 8, here's positive 8. Can x be equal to positive 8?
Yes.
Yes, closed point. What direction do I shade? To the right. My greater than is to the right. Now we do the other piece. Or x is less than or equal to negative 8. Can it be equal to negative 8?
Yes.
Yes. And then less than is to the left. So and problems always have shading in the middle. or problems always have shading on the outside. Because it's all talking about your distance away from 0. And if your distance from 0 is less than something, it should be really close to 0. If it's greater than something, it should be further away from 0. What is the piece that I skipped on number 1? Solve the absolute value inequalities for x, that's right here. Graph the solution on a number line, that's right here. Write the solution in interval notation. So that's the part we skipped on accident. How do I write all of these solutions in interval notation? Very good. Parenthesis, -1, comma, 7, parenthesis. The parentheses just mean I can't have that value as one of my solutions, right? I don't have a closed point at -1 or 7. But all of my answers are between -1 and 7, so it has to start at -1 and go to 7. Interval notation over here. Let's look at our number line to determine this. What's my lowest value? -infinity. And that goes all the way to -8. Can you have a point at -8?
Yes.
Yes. X can be equal to -8. You could plug in -8 and it would give you 5, which is equal to 5. But we need to keep going on the right-hand side. Where do we pick up at? +8 and goes to infinity. So this is your interval notation for number 2. Questions? All right. Next problem. Is my absolute value isolated? If there's anything outside the absolute value, it is not isolated. -2/3 is being multiplied by this absolute value. How do I get rid of it? Good. Multiply by -3/2, which is called the reciprocal. Could we have done that on the second problem over here? Yes. This is just multiplying by -3 and then dividing by 2. If you would have done that all in one step over here, you would have multiplied by 4/3 and it would have acted exactly the same. Sometimes it's easier to just multiply by the reciprocal. Alright, so negative times negative is positive. 3 times 2 and 2 times 3. That gives me 6/6. What does 6/6 equal? 1. And 1 times any absolute value is just that absolute value. So basically, these cancel each other out. This fraction we want to multiply straight across. What happens when you multiply by a negative number? Your inequality sign flips. Now we want to multiply straight across. 6 times -3 is -18. 1 times 2 is 2. Can I simplify that? What do I get? Anybody? 9. -9. All right. Bless you. I have isolated the absolute value to the left-hand side. Number 2, is this a special case?
Yes.
Yes. How do we know it's a special case?
Because it's negative.
My b value is negative. That means I'm going to get my answer right after I determine which type of special case it is. So, what type of number do you get when you take the absolute value of something? A positive number. When is a positive less than a negative number? Never. Positive numbers are never less than negative numbers. So that's a false statement. Or you can write never. So my answer here is going to be no solution. Very good. Do I need to graph it on a number line? How do you graph something on a number line that you have no solution for? You cannot. We have to have a solution in order to plot it on a number line. But please go back up to the top. What do I do if there's no solution? Explain why. So we're going to write out a sentence. There is no solution because the result of an absolute value cannot be less than what? Yeah, you could put a negative number, you could put -9, you could put a negative. Cannot is one word, but I wanted emphasis on the not. I should have wrote it as one word. Alright. Questions? Alright, going on to number 4. I don't have an interval notation over here if there's no answer either. If there's no interval to write. What's extra to my absolute value?
1/2 and 7.
Good, 1/2 and 7. Do you get rid of multiplication first, or do you get rid of addition first? Addition. So we're going to subtract 7 from each side. How do I get rid of 1/2? Multiply by the reciprocal, which is 2/1, or just 2, right? That equals 1. So 1 times my absolute value is my absolute value. Does my sign flip? No, just because this is a negative, if you're multiplying a number to the other side, I didn't multiply the negative to the other side. So this is my sign's gonna stay the same, and I get a -6. Is my absolute value isolated?
Mm-hmm.
Yes. Is this a special case? Yes, another negative number. In what cases is a positive greater than or equal to a negative number? Always. Positive numbers are always greater than negative numbers. Therefore, my answer is all real numbers. Very good. Okay, this is something that you can show on the number line. How do I show my solutions if every real number is a solution? So I think I heard interval notation a second ago. But yeah, this is going to go to the left forever, to the right forever. All of these numbers in between are solutions. So negative infinity to positive infinity would be the interval notation for that. Questions? All right. These are both composite functions. Does anyone remember what a composite function is? What f of g of x means?
You combine them.
Something about combining them. F of g of x specifically means you plug it in. So you're gonna take the g of x and plug it in for the f of x. But before we start doing those things, I think it's easiest to isolate your composite part of your function first. So what's extra on the left-hand side here? Plus 2. So I'm going to subtract 2 from each side. Okay, now I'm going to do my composite part of my function. G of x goes in for the x in the f of x function. Is my absolute value isolated? Yes. Is this a special case? Yes. When is a positive less than a negative? Say never. Okay, so what's my answer? No solution. Good. On the right-hand side, what is extra here? The 12 and the negative 3, but we get rid of the 12 first because we're doing our order of operations in reverse, which means we deal with addition and subtraction first. All right, what do I deal with now? Negative 3. Does that mean f minus 3? Does that mean negative 3 plus f? Does that mean negative 3 times f? Times. So how do I get rid of it? Divide by negative 3. What happens when you divide by a negative?
The sign flips.
Good. Flip the sign. We get a positive 1 and an f of g of x left, because negative 3 over negative 3 equals 1. Now you can plug it in. Plug your g into your f equation, wherever you see the x. Okay, I'm going to continue solving this on the right. So I'm just going to rewrite it. Is this a special case? No, my 1 is not a negative number. So is this an and problem or an or problem? And. Less than tells me it's an and problem. So 2x plus 5 has to be between 1 and negative 1. How do I start solving for x? How do I start solving for x? What should I do? We're right here. Subtract 5 from not just two sides, but all three pieces of our inequality. Negative 1 minus 5 is Negative 6. I have 2x left in the middle. And on the right-hand side? Negative 4. Is x by itself? Not yet. What do I divide by? 2. So you get negative 3 is less than x, which is less than negative 2. Can x be equal to negative 3? No. Can x be equal to negative 2? Only the values in between, which means it's only fractions or decimals. Okay, so I have inequality notation. I have it written on a number line. What's the last thing I need? Interval notation. What number do we start with? What number do we end with? Good. Negative 3 to negative 2. Why did I use parentheses on both? Because they're open points. X can't be equal to either of those numbers.